Hey guys, welcome to Elimination Method Part 2. So this will help you with IXL questions that I'll want you to do beyond a score of 70. So before we get into that, we remember in Part 1 we were able to add and subtract equations as long as they were lined up nicely. Another thing that we can do with equations is we can take an equation and multiply it all by a number. Okay. So, for example, I can put parentheses around everything here, and maybe I'll multiply it all by, let's say, 3 here. So then it's distributing pretty much. So I'm distributing the 3 to each term in the equation. So then in this case, that'd be 12x plus 15y equals negative 18. Okay, and that's a legal thing to do. We can multiply a whole equation. So now these are equivalent equations. Just this one's 3 times the one above it. Another thing we can do, we don't do this as often, but if you look closely, these are all divisible by 4. So one could say, oh, you're going to divide the whole equation by 4, and that's what you could do. But we usually just say we're multiplying. So if you want to multiply and reduce these numbers, you can multiply them all by 1/4, which is possible, okay? And multiplying by 1/4 is equivalent to dividing by 4. So in this case, that would be, and if you want to verify, you can put all these over 1, and then that'd be 12 on top, 4 on bottom, and 12 over 4 is 3. And another way to, so essentially we're taking 12 divided by 4. So 8 divided by 4 is 2. And 44 divided by 4 is 11. So that's another situation you can do. Okay. And I guess I didn't show it, but you can also multiply by negative numbers. Just like in this case, if I multiply by a negative 3, let's say, then all these would change their signs, right? This would become negative 12, this would become a negative 15, and this would become a positive 18, right? Just like you would when you multiply with negatives. Here, so you'll notice that if we tried just adding or subtracting these equations, we would not get a variable to eliminate because this is a negative 1 plus -5 doesn't cancel. -1 minus -5 wouldn't cancel either. Same thing over here, 3 plus -6 and 3 minus -6. We're not going to get any canceling. So we're going to utilize the fact that we can multiply the equations to force the coefficients to be numbers that can be added or subtracted to be eliminated. So if you recall, we're looking for opposites, opposite signs. So like if this is -6, we could maybe make this a +6. Maybe you can think about how we could do that. And the other option would be having the exact same sign because then we could subtract them. I prefer to add, so I'm going to look for opposites. So I know -6, I could make this into a +6. Hopefully you were thinking multiplying by 2 because that's what 3 times 2 is 6. So that's the opposite then. I'll write that over here now. So that'll be -2x plus 6y. Remember, we're distributing equals 2. Now, since this already is set up nicely, I'm just going to rewrite this one the way it is. So -5x minus 6y equals 5. All right, and like I was just saying, we're going to add these in order to cancel the opposites on the y coordinates. So to cancel those, we'll cancel those. Those do make 0. And now -2 plus -5 is -7x. Just writing it over here a little more. And then 2 plus 5 is 7. We can then solve for x by dividing by -7. And the -7 divided by -7, they become 1. So we can say that they cancel because 1x is just x. And 7 divided by -7 is -1. All right, awesome. So we've got the first part of our answer, -1. All right, now to find the second part of our answer, we want to plug this -1 in for one of the x's of the original problem. So we can plug it in for this x or this x. It really doesn't matter which one, as long as we do our math correctly. Um, so let's see, I'll plug it into this top one. So that'd be -1, or remember I wrote that in so I wouldn't have to have that. That just means the opposite of x. So if x is -1, the opposite of x would be +1. So I'll write that here. +1 plus 3y equals 1. So then we can subtract 1 from both sides. That cancels here. We're left with 3y equals 0. And that's okay, right? Sometimes people think that means we have to say the answer is no solution, right? 0 can be an answer, because then when we divide by 3 here, the 3's cancel, and y is equal to 0, right? 0 divided by 3 is 0, and 0 is a coordinate that we can have, right? That just means this point is an x-intercept, right? It's on the x-axis. All right, so here's example 2. In this case, it's another situation that's a little different. Again, we can't just add the equations or subtract the equations to eliminate a variable. But then there's an extra challenge here in that if you look at any, like, let's focus on the y's first. So -2, I can't multiply -2 by any nice number to get the same or opposite of -3, right? I think, well, it would be 1.5. So -2 times 1.5 is -3. But I'd like to avoid multiplying with decimals and fractions because we don't need to. And I'll explain why in a minute. But also, we should check the x's. And I take 4. Again, there's not a nice whole number, positive or negative, that I could multiply 4 by to get 5. So what we do in a case like this is we multiply both the top and the bottom equation. And we're trying to get the coefficients of one of the variables to either be the same so we can subtract them, or opposites so we can add them. So it doesn't really matter which one we pick. I'll focus on the x's this time. So we're thinking, what number can both 4 and 5 multiply into? What is a multiple of both 4 and 5? So the most obvious answer, there's more than one answer, but the most obvious answer I think is 20. So I can multiply this top one. 4 times 5 is going to be 20. And then I'll multiply this bottom one. So again, remember, I could multiply it to get it to become 20, or I could make it become -20. I prefer adding the equations, so I would like to have opposites. So instead of multiplying by 4, I'm going to multiply by -4, because then I'll have a -20 on the bottom and a +20 on top. And then I can just add the equations. So let's see. Distributing this 5, we'll get 20x minus 15y equals 15 times 5 is 75. All right, the red equation here, that's going to be -20, like we said at the first. Now be careful here. -4 times -2 is +8y. And then -4 times -11 is 44. All right, so we got a little bit bigger numbers, but that's no problem. We can handle this. Add this to cancel those 20s. And then -15 plus 8 is -7y. 75 plus 44 is 119. Now, believe it or not, I do think that -7 goes into 119 nicely. Let's think about this. So -7, well, it's going to be an answer that's negative. And kind of doing long division in my head. Well, I put the 1 there because I know that 7 goes into 11 once. Then there'd be a remainder of 4. Drop the 9 down, that'd be 49. 7 goes into 49 7 times. So y is -17. So we could start writing our answer, but the -17 goes in the second position. Now for substituting it back in, -17 is a y value. So we could either put it for this y or this y. I'll do the bottom equation. So let's see, that'd be 5x minus 2 times -17 equals -11. And then we're just solving for x then. So multiplying the -2 times -17 is +34. And then we can subtract 34 from both sides. That cancels. And then we're left with, what do we got here? 5x still on the left side equals, what is that, -45 on the right. And then we can divide both sides by 5. And x equals -9. So that is the x coordinate of our ordered pair here. All right, let's look at a third and final example here. So taking a look at this system of equations, you can see it's kind of a mess. Hopefully you notice that they're not lined up nicely. The only thing that's really lined up are the equal signs. Everything else is kind of out of order. We need to rearrange at least one of these equations so that they're in the same form. Okay, and they don't have to be an official form like standard form or y equals mx plus b slope-intercept form. It's kind of nice sometimes to have them in those traditional forms, but as long as they're lined up, where the x's are in a line, the equals are in the line, the y's and the constants, we can add or subtract the equations. So let's see here. I think I think I'm gonna put it in standard form because I see I can move this y, cancel it, and move it to the left by subtracting 24y from both sides. And that will cancel the 24y's on this side. And on this one, I can just move the x over by adding 5x. So that way I'll have them both in standard form with the x and the y on the left and the constant on the right of the equal sign. So let's see here. Rewriting this one, that'll be, I'll put the x first. So 12x, then minus 24y equals 17. And this other one, I'll put the x first again, so it's a positive 5x minus 10y equals, what is that, -3. Okay, awesome. Now, so we got them in the right order, but we still are going to have to multiply, I think, both equations again in this one. So we could pick on either the x's or the y's. Let's just do the x's since they're a little smaller numbers, I guess. So I notice I can multiply this by 5 and this one I'll multiply by 12 then, right? And so then that way the x coordinates will be the same, right? 5 times 12 is 60. All right, so I'll rewrite these down below here. So working my way down. So the blue. So 5 times 12 is 60x 5 times negative 24 is negative 120y. And then 5 times 17 is 85. Okay, doing the same thing with the red one. So 12 times 5 is 60, like we wanted. So looks like we're gonna be subtracting these to cancel because they're the same sign. Now this is when something interesting happens. 12 times negative 10 is negative 120, which is the same as the y coordinate as well. So notice that we have the exact same scenario on the top blue equation and the bottom red equation. And then multiplying, that's going to be negative 36. All right, well, let's say we didn't notice that. We would just keep doing what we know to do. They're the same signs, we would subtract. 60 minus 60 cancels, right? It's 0. So that goes. But negative 120 minus negative 120 also cancels. So these both cancel. All right. So you could think of it as 0x plus 0y. But 0x and 0y are both 0 themselves. And if you add 0 with 0, you just get 0. Okay. Drop the equal sign. And 85 minus negative 36 is the same thing as adding a positive 36. So what is that going to be? 121. But really, we don't really need to know exactly what that is, just the fact that it's not 0. Because this is one of those special cases. This is a false statement, right? 0 cannot equal 121, right? That can't be. There are two different numbers. The equal sign means that they're supposed to be the same on both sides, right? This is not true. So this is false. Since it's false, if you recall, that's when we say there's no solution, okay? There's no solution. These two lines will never cross at an ordered pair. And if you think about what that means for their graph, maybe try to remember, what does that mean? What does that mean that their graphs will look like if they never intersect each other? If you're thinking parallel, then that's exactly correct, right? So these two lines might be looking something like this, right? Where they're running alongside each other. They don't have to be close. They could be far away from each other, but they're parallel. They're never going to cross. No solution. Another symbol we could use is the circle with a line through it. That's called the empty set symbol. So I'm not going to go over an example, but like this. But if you had another situation where it's the same number on both sides, right? Like 0 equals 0. If you were to get 0 equals 0 or something like that, some true statement, then remember we say infinitely many solutions. And infinitely many solutions, we don't say all real numbers technically, because this this is the solutions in this case, remember, are ordered pairs. So basically it's saying that we have infinite amount of places where the two lines cross, but that doesn't mean they cross at every point that exists on the plane. All right, there's plenty of points out there the lines don't touch, but this is what it would look like. You would almost, you probably wouldn't be able to tell that there's two lines there because they're the same line. And every point on this line they're intersecting at. So, there's all the points, and I could go through it again, and it keeps going on, down and up. So infinitely many solutions would be what this would be like. All right, so the assignment now is to try to get up to 100. I don't think that you will have problems where you have no solution or infinitely many solutions on IXL. I might try to find some other ways for us to practice after this, but as of right now, I'd like you to get up to U.10 up to 100. Remember, the other ones are U.1, U.2, 4, 8, and then the bonus stuff would be 9, 11, and then I believe it's 14 where you can use any method to solve the system. Okay, so please at the minimum do the, with 10 here. This is the minimum scores up to 100 on just U10. These ones you can get up to 80. That's the minimum of what I'd like you to do. Um, though I would like you to, if you are able to, and you have the time and you're understanding this well enough, do 9, 11, 14, up to as high as you can, and then maybe even try to get these up to 100 as well. That would be awesome. Um, Otherwise, general practice, you could do any of the recommended skills, the math recommended skills on IXL, or you can go into the diagnostic arena for the program to figure out more recommended skills to show you. So, all right, don't be afraid to contact me on Google Hangouts, or Snapchat if you prefer, or email. Um, I'm in my classroom today, at least until 11:15, and I'll try to be available again in the afternoon. All right, talk to you guys later.